Welcome back to AWS DevOps Logistic YouTube channel. Today we are going to discuss about Kubernetes. In Kubernetes, especially we are talking about node affinity. Okay, let's get into topic. Let me share my screen. Can you see my screen?
Yes, sir.
Yeah.
Yes, sir.
1 second. Did you practice? Is it working now, Ishwan?
No, sir. I tried later for some time. It did not work that in that DM. I destroyed everything, sir. I have to create and to try.
Okay, why it's not happening? Why it is happening? Why it is not able to create?
No, no, sir. With that DNS, how much ever I create the clusters, it is not working, sir.
Okay, we'll see that. So yesterday I've shown you, right? And two times you have ran that, and in front of me. Yesterday we have seen that, right?
Yes, sir. Sir.
Yesterday I've shown you, and we have created deployment. Also, we have created service. We have.
Sir,
Uh,
everything we have done. Only
yes,
that
yes.
browser we could not. Yes, sir.
Mm,
Yes, sir.
okay. Anyways, we'll see that. We'll do troubleshooting. Okay. Yeah. So I think just give me 1 second. Let me check. So today we are going to discuss about node selectors. Okay. So what is node selectors? It's a part of selector, but it's important topic. Okay. So in this node selectors, for suppose if we have three nodes, node 1, node 2, and node 3, right? Three nodes you have, node 1, node 2, node 3. For suppose these three nodes are different sizes, different specifications, right? Okay. So one is large, other one is maybe small. Okay. In this case, what will happen is, so node selectors, by using node selectors these are all different nodes, node 1, node 2, node 3. If it is these three are different sizes, if I have a pod, a larger pod or medium pod, small pod, okay, these type of pods will be the how we have to place and all. So if the size is how we have to place. To solve this issue, we can set limits, okay, on pods. Okay, for example, if it is high resolution, these two are, resources. These two are small resources. Okay, so for this we have node selectors. First one is node selector, and second one is node affinity. So these two topics are there. These two topics can solve this issue. Okay, right? So
Yes, sir.
this is a, for example, both are same, API version 1. Okay, so pod, so this is actually manifest file. In this manifest file, if you can observe, see here, one node selector we have mentioned, right? In this node selector we have mentioned size large. If it is small, we can keep small. If it is medium, we can keep it medium, right? So how can, so the question is, that is fine, we can keep node selectors like this, fine. In manifest file, yes, we can keep. But so the question is how we can label the nodes. This is what we have to know, right? Correct. 1 second.
Yes.
So yes, so for example, this is a command. Okay, we can mention like this: node selector. For by using node selector we can mention like this. So kubectl node name and key value. Okay, label key and value. So for example given below. So this one, kubectl label nodes. Okay, this is node 1. Okay, size equal to large. This is what we have mentioned here. Is it correct? Right. In the manifest file we have
Yes, sir.
mentioned like that only, right? Node selector.
Yes, sir.
So and
Selectors
also
mentioned.
we can give like this also, right? Declarative part and imperative part,
Yes.
right? So
Yes,
and
sir.
which means this is label key, this is name, and this is value. Value is large, which means this, right? This one. So this time with the node selector set to a size of the large. Okay, and when the pod now created, it is placed on the nodes as desired. Okay, node selector served our purpose, but it has limitations, right? It has limitations. Okay, so we use a single
Yes.
label and selector, a single label selector. Okay, to achieve our goal here, but requirement is much more complex. Okay, require, for example, this is very simple one, but my requirement is very complex. Situation is very complex. For example, for suppose something like place the pod on a large or medium node, large and medium node, or something like place, we have to place pod on any nodes that are not small. Okay, maybe if it is not small, if it is not medium and large. Okay, that something like complex. Okay, you cannot achieve this using node selectors. Node selector one single label is fine, but multiple comes up, and if it is small, medium, large, if you want to mention all together, or if it is complex, then it is kind of little tricky and difficult for this node affinity. So for that also uh, called we have concept called node affinity and anti affinity. These two features are there, right? So what is node affinity? Okay, what is node affinity? First we have to see that. Okay, this is not my document, I got it from somewhere else. I'm just using it for our topic purpose. Okay, I'm finding somewhere else, I'm finding the resource I'm getting from GitHub. Okay, and I
Yes,
copied
sir.
from some GitHub. This is not my document. Okay, so node selector, right? uh, so yes, we have seen this, right? Two times copied. Okay, no problem. Okay, node affinity. Node affinity, what is node affinity? In Kubernetes, the primary purpose of node affinity feature is to ensure that pods are hosted on particular nodes. Okay, you understood this? Pods are hosted on particular nodes. In this case, to ensure the large data processing pod ends up on the node 1. In previous we have seen we did using node selector, right? Previous one, last top
Yes, sir.
on top of this page. Okay, so as we discussed, we cannot provide advanced expressions like, or not with node selectors. Advanced concept if comes, node selector cannot handle, right? That's why node affinity came into the picture,
Yes, sir.
right? So the node affinity feature provides with advanced capabilities. Understood? Single purpose, yeah, it can handle what node selector can handle, but when it comes to the advanced features, node affinity come into the picture, right? So the sample node selector specification will now look like with node affinity, this, right? So this is for node selector. Okay, node affinity is like this. So to compare, I again copied here in this. Understood? So if you compare this, can you check once? Can you cross check? Look at this one and this one. Hmm?
Yes, sir.
Yeah, this is simple little complex. Node affinity we have mentioned, right? And we have mentioned all these things, parameters. Okay. So and then node affinity
Yes, sir.
under that, and then you have a property that looks like a sentence, right? This property look like sentence, right? Big one, a big say required during
Yes, sir.
schedule and
Got it.
ignored and during execution. Node selector terms, match
Yes, sir.
expressions, key separated, operation value separated, large and medium. We have mentioned everything is like this. Okay, okay. So then you have node selector terms like uh, in this node selector you have only one thing. This is simple, but it cannot handle larger one, but it can handle larger. That is why the difference is like that. Okay. So 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 the key value pairs are in the form of key operator, key operator, right? And value also, values large medium. Okay, where operator is where operator is an operator ensure that the pod will be placed in a node. Okay, pod will be placed in a node, okay, whose label size has any value in that list. Okay, any value, not mentioned any value. Okay, so specified here, no, here not mentioned. Okay, in this case it just one called large. Okay, for suppose this value what we have mentioned, for example, one is large, one is medium. For example, if it is small, these are all comes under, you see this Yashwant. So these values comes under, these are all values, right? Sub values, values part, this large and medium is part of this values, right? Correct. So in this
Yes, sir.
node selector we have mentioned only one. So in it has only, it can handle only one, but in this case we have given multiple large, medium, and so like that, right? So if you want, if you think your pod could be placed on a large or medium, okay, so you could simply add the value to the list, value like this. Okay, you could use the node, excuse me, you could use the node in operator, says something like size is in small. Okay, like, so where node affinity will match the nodes with the size not set to small. Okay, if you know, we have only set the value size to large and medium nodes here. For suppose here we have set large and medium, okay, values. Hmm? So the smaller node does not even
Yes,
have the label, right? Even we don't have smaller label. Okay, so we don't really have to even check the value of the label, right? Because we do not mention any smaller value, right? So as long as we are sure we don't set a label size to smaller node, right? Smaller not mentioned, so no smaller node. Okay, using
yes,
the
sir.
exist operator will give us the same result. Okay, the exist operator will simply check if the label sizes exist on the node and you don't need the value section for that, as it does not compare the values. There are number of other operators as well. Check the documentation for the specific details. Now we understand all of this, and we are comfortable with the creating this. Okay, so when the pods are created, these rules are considered, and pods are placed into the right nodes. Okay, why all we are doing all these things? Okay, for example, this is one, this is one node, this is one node. Okay, so we have a pod, a small pod, big pod. So which means this is large, for example, for suppose this is large node. Okay, this is small, for suppose small, this is small, for example this is medium. Okay, pod, these are all pods, these are all pods. Okay, so the intention of these things are, we need to place whatever the specifications, configurations are there. According to that, we need to place the right node, pod into right node. You understood?
Pods.
Yeah, right
Yes,
pod
sir.
into the right
Yes, sir.
node. Right, when the pods are created, these rules are considered, and then pods are placed into the right nodes. These nodes, whatever the pods will be clumsy here and there, here and there, but it has to be matched. Okay, with the right pod should be in a right node. Right pod in a right pod, for example this is larger pod should be in a larger node. For example, it does not have that much of capability. If you want to keep this small larger pod in this small size of node, it doesn't works. Okay, what if node affinity could not match? Okay, a node with given expression. Okay, what if, the question try to understand, what if node affinity could not match and a node with given expression? Okay. Hmm? In this case, what if we are no nodes with the label called size? No nodes with label called size. What if some changes, okay, and labels on the node at a feature point in time, right? So will the pod continue to stay on the node? You understood, na? So what if this node is not match? Okay, what if node this is some medium, this is small one, small pod. So do you think that this will continue stay longer node in this? It is ephemeral. Anything will happen. If it not
Yes, sir.
matches, it will. Okay. So to set the proper node for proper pod, so this scheduler will do this to set the proper node to proper pod. Okay. So for that it will match by using node selectors and node affinities. Okay. So scheduler will decide, yeah, this node is okay. Node 1 is there and node 2 is there. Node 3 is there. So okay, fine. This medium size is one is there. This should be suitable to the node 2. Okay. Something like this. All of this answered by the long sentence like property under node affinity. Okay. So the type of node affinity define the behavior of the scheduler with respect to the node affinity and the stages in the life cycle of the pod. Understood? So there are
Yes.
uh, currently two type of node affinities available. Okay, for example, I'll scroll it down. See, two types: type 1, type 2. So this is 1 and this is 2. Okay, so if you can see this here, two types. What are all those? See, these two. Node affinity types, you see this is planned,
Yeah, yes, sir. Yeah.
correct? So these
Yes.
two, so required during this execution, and this one, these two types are available. Okay, type 1, type 2, type 3, type 4. Type 1, required, preferred, ignored. So these are all scheduler will decide, actually this is for knowledge I'm telling. Okay, so and also if you set the proper pod to the proper node, it will be very longer. You understood? Pod should not get disturbed. If it not matches the configuration and the proper specifications, what it will happen, pod already it is ephemeral, right? Anything will happen. So this is the concept. I hope you can understand. Okay, we'll see practical in next class. You understood, right, about this?
Yes, sir.
Yeah.
Yeah, yeah, yes, sir.
Yeah, so right, the agenda of this uh, class is simple. uh, the motto of this node affinity and node selector is, the node should be in a proper place, sorry, the pod should be proper place, like nodes. Okay, it should be in proper node. So by using node selector, yes, we can do, but it cannot handle more complex issues. Okay, for example, node affinity, yes it can, because it can handle multiple. Okay, and also it is complex also, it can handle. By using this, you can see the multiple examples. See this one, node selector, something medium size, this is large and medium, this is for small. Okay, operator not in, so value small, like this. So if you see here, this operator exist or not exist. If it is not exist, what will happen? Tell me. If it is not exist, for suppose the pod is there. Okay, nodes are there, different nodes are there. Selector also we are not doing anything. So what scheduler will do is, scheduler will arrange anything. So suitable one. Okay, understood? That's all.
Yes, sir.
So
Yes, sir.
this we'll see one example tomorrow if you get ready. Okay, try to resolve your issue. Okay,
Yes, sir.
so is it are you
Yes, sir.
still doing troubleshooting, or shall we do that now?
No, sir. Before the class, starting the class, I've given the DNS names. Changed the names as well, sir.
So you do
I
one thing
think it may be up.
before start the class. You should keep minimum,
Yes, sir.
after keeping the DNS names, you should keep at least 20 minutes gap. Understood?
Yes, sir.
Server cannot
Yes,
able
sir.
to handle. Okay, so it we DNS name four places will get, like UK, US. Okay, or .org something will get.
Yes,
So
sir.
it will take a time. Okay, so DNS
Yes, sir.
server should be proper. So that's why after keeping the DNS names, you should be you should keep at least 20 minutes. So after 20 minutes, you can run the cluster. You can create the cluster. Okay, with your required specifications, like how many nodes you want, how many uh, pods you want. Sorry, how many worker node, how many master nodes you want. Understood? So then only you will get proper, you have to maintain proper
Yes, sir.
time. Okay, duration of the time, it will take a time to set up all these things, right?
Yes, sir.
Fine. Okay, just give some more time, just give some gap for that, and after that you can try, maybe tomorrow
Yes,
morning.
sure, sir.
Okay,
Yes, sir.
all right. So
Yes, sir. Now
we'll
I
see.
have added changed the names as well, sir. It's
Hmm.
been almost 15 to 20 minutes.
Hmm.
15 minutes is over, sir.
Okay, I'll do
I
one
will
thing,
try
after 10 minutes or
another
15
10
minutes,
minutes.
you just ping me,
Yes, sir.
I can join with you in troubleshooting.
Yeah,
Okay.
yeah. I will check, sir, once. Try. I'll try.
Okay, okay, fine. All right.
Yes, sir.
So, fine, Yashwant. We'll see you in next class. Take
Sir.
care. Bye.
Yes, sir.